mentor of mine. He is a professor of entrepreneurship at Stanford and Berkeley. And I met him a couple of years ago at Berkeley when I was signed up for his class accidentally. And I went to the first one just to see what it was about. And it wound up not fitting into my schedule that spring, but it was so compelling that I took it on as an auditor. I went to every single session just because the class was so good. So you're really in for a treat here. Steve is a historian, and he's going to be telling us 4 stories about the history of the tech sector that should give us some really good perspective on our own time. So please welcome Steve Blank.
Thanks, Sarah. Glad to be here today and be with all of you who are inventing the future at the edge. And so what I want to offer you today is a couple stories. Not technology, not a product announcement, but just a couple of stories about how some of us got here in a way you might not have imagined. The title of the talk is Days of Future Past, and for those of you old enough to remember, it was a Moody Blues song. But it's also about entrepreneurs who invented the future. So just some definitions at first. I tend to think of the life cycle of a startup to a large company as starting on the box on the left. That startups exist for one reason. A startup is an organization used to search for a repeatable and scalable business model. It's the only reason there's such an organization. Entrepreneurs are the individuals who are great at doing anything necessary to find that business model. And as companies evolve from left to right, they go through a transition, which is a polite way for saying that most entrepreneurs don't make the transition. And then they eventually become large companies. And in large companies, different people take over and execute this found and known business model. But when you're a startup, the skills needed to search and find this business model are agility, tenacity, resilience, innovation, pattern recognition skills. Things we see and hear about every day when we hear the stories and see at conferences like this, successful entrepreneurs. And in large companies, this is the execution of a business model. This is where companies grow from small ideas into billion-dollar organizations. Here you need focus, you need process, you need plans, you need to manage personnel, and you need to execute. And what I'm going to do today is give you 4 stories about entrepreneurs and how they grew their companies or organizations. And the first story is about why Silicon Valley isn't Boston. And it's the story of Fred Terman and James Killing, Stanford versus MIT. The father of Silicon Valley is not, as some of my students used to remind me at Stanford, Steve Jobs. It's when I asked them to think about somebody really old, that's who they kept coming up with. Kind of a little sad. It's not even Gordon Moore and Robert Noyce, who we'll talk about in a second. It's not even Hewlett and Packard. The irony is, of course, when I asked this question, we're standing in the Terman engineering building. And the father of Silicon Valley is a guy you've probably never heard of called Fred Terman. Terman was a professor of engineering at Stanford in the 1930s, became dean of the engineering school in the 40s, and the provost in the 1950s. But what's really interesting about his story is he became the expert of the high tech of his era, which was radio engineering, and wrote the textbook. And when World War II broke out, the U.S. government enlisted professors and graduate students in enormous technical projects, some of which you might have heard of, called the Manhattan Project, making the atomic bomb, and some of which you may never have heard of, which is building radar at the MIT Radiation Laboratory, and one I'll guarantee you never heard of, is building electronic warfare devices to shut down the German air defense system that U.S. and British bombers needed to fly through in World War II. Fred Terman was drafted, figuratively, by the U.S. military to build a research and development group located in Harvard. And he built 800 of the best radio engineers to build these devices, and he became the father of electronic warfare. When he came back to Stanford in the 1950s, he continued his work in this field, except this time it was in secret. Terman turned Stanford into the arms center for the National Security Agency and the CIA. And by the way, in World War II, when the military was doling out R&D dollars, Stanford got all of $50,000 for teacher training. The U.S. military at the time thought Stanford's engineering department wasn't any good at all. In fact, the only good person there was Terman, which is why they took him back east. Now, contrast this to this guy. He ran what could be considered the technology empire, MIT. In the 20th century, MIT was the center of engineering in the United States. East Coast school, been there forever, and had deservedly a spectacular reputation. Guy who ran it, James Killian. President of MIT, had tons of military labs. And by the way, in World War II, when Stanford got $50,000 in government R&D, MIT got $117 million. 50,000, $117 million. But in the 1950s, when Terman returns to Stanford, his goal is to make Stanford the center of engineering in microwaves and electronics and match MIT contract to contract. And this scrappy university that didn't even show up on the radar in electronics pre-World War II, by the 1960s becomes preeminent in military electronics. Terman versus Killian. Stanford versus MIT. MIT in the 50s and 60s turns into, in the middle of the Cold War, the electronics arms merchant for the U.S. military. Builds the Sage air defense system. Builds missile guidance systems. Stanford turns into the arms merchant for the CIA and NSA, building electronics intelligence and electronics warfare equipment. But Terman does something at Stanford that's unique. Starting in the 1950s, he starts encouraging his students and his faculty to leave Stanford with all the intellectual property they wanted to take and start companies. He decided that, unlike MIT, Stanford should not get into the production business. That it should be individual companies around Palo Alto and Mountain View that were actually going to build systems. Entrepreneur, entrepreneur. Terman versus Killian. The rise of Silicon Valley is another interesting story. It's called Silicon Valley. Unlike Terman's vision, which would have been Microwave Valley, it's called Silicon Valley. And many people don't think long enough about how did it happen. The first silicon company in what became Silicon Valley was started by this guy, William Shockley. It's a name that most of you probably don't know. But Shockley came out of AT&T's Bell Research Labs. He was the co-inventor of the transistor in 1947, and in 1956 he won the Nobel Prize for this work. Shockley decides that he doesn't want to work in a research lab for a big company, so he leaves AT&T and travels to Mountain View, California, and sets up the first semiconductor company on the West Coast. The first guy to bring silicon to the valley. But while he was the first, the founders of Silicon Valley are two people that you might have heard of: Gordon Moore and Robert Noyce. Moore and Noyce didn't have this pedigree. They didn't win Nobel Prizes. They didn't even work in large research labs. They were just great engineers. And they went off to found two companies. Just two. One called Fairchild Semiconductor, the other called Intel. Every chip company in Silicon Valley traces their lineage to the companies these two guys started. And rightly so, they are remembered as the founders of Silicon Valley. But what's interesting is Shockley versus Noyce and Moore. Shockley started Shockley Semiconductor, and if we were to draw the org chart of all chip companies in Silicon Valley in 1956, this would be the diagram. There it is. Shockley Semiconductor. But what happened is Noyce and Moore actually came out to Mountain View, California to work for Shockley. And they found out that he was the world's worst manager. I'm sure some of you are thinking, no, I work for the world's worst manager, but I think this guy set the record. And after 15 months, 8 of his best people leave Shockley Semiconductor, including Bob Noyce and Gordon Moore. Noyce and Moore go off, as I mentioned, and found Fairchild and Intel. And while you can't read this eye chart here, it basically shows that in 20 years after they left Shockley and started Fairchild Semiconductor, 65 chip companies, 65, every chip company in Silicon Valley were spin-offs from either Fairchild or later Intel. These were the founders of Silicon Valley. But what happened to Shockley? Moore and Noyce created a $100 billion industry and transformed the world. Shockley sold his company once, sold it again, got shut down. That's what his diagram looks like. He dies alone, unsuccessful. This was a big company guy, horrible manager, founder. World's best pedigree, world's worst manager. World's best talent spotter. But it was his way or the highway. And the two guys who picked the highway were the entrepreneurs. Moore and Noyce, founders of Silicon Valley. Another story, the rise of the personal computer. Most of you recognize this guy. Anybody know who that is? Okay. I was going to use the police mugshot, but I thought that wasn't... there is one, by the way. Bill Gates. So everybody knows the Bill Gates story. College dropout. I love to say that. I love to say that because Bill Gates never would have even been asked to interview at Google. Microsoft, for most of you don't know, had nothing to do with operating systems. For the first 4 years of the company's life, it made computer languages. Eventually got into something called Xenix, which was a Unix variant, but it was basically known for basic, we do Fortran and COBOL and eventually Pascal. But in 1980, somebody came knocking on the door. It was the monolith of the computing industry. It was IBM. And they were putting together a secret project to build a personal computer, and they needed an operating system. Their first choice had been CPM from Digital Research in Monterey. And for lots of reasons, that looked like it wasn't going to work out. And they were visiting Microsoft to license their languages for this new PC, and they happened to ask, hey, know anybody who has an operating system that looks like CPM? And Bill Gates said, why yes, we have one. And like, Paul Allen looks across the table going, what? We don't have one. Yes, we'll show it to you tomorrow. He sold IBM an operating system he didn't even own. Went across town, licensed it for $25,000 from Seattle Computer, which he later paid another exorbitant $50,000 for all the rights. Now, the guy who was actually building the IBM PC inside of IBM was Phil Estridge, a true innovator inside a massive company. Estridge was an IBM veteran, had worked there since 1959, but ran an internal skunkworks, a secret project far removed from IBM corporate in Armonk, New York. They stuck him down in Boca Raton, Florida. A city, if you've ever been there, you need a passport if you're under 75. But he grew this division from 12 engineers to 10,000 employees in 4 years. Went from 0 to 1 million PCs, 4 years. From 0 to billions of dollars in revenue, where no one at first at IBM even wanted to talk about a PC, to a division that became a political football inside of IBM. Gates versus Estridge. Gates was just a supplicant. He was just going to license the software to IBM. IBM was going to offer DOS and CP/M and other operating systems as well. After 4 years, Estridge loses his division in political turf wars inside of IBM. They promote him to some great title, VP of manufacturing, whatever. He was never going to see his PC division again. And just as he was contemplating his future, he dies in a plane crash. My prediction was he would have left IBM within 18 months and joined some startup. Bill Gates became the world's richest man by beating Estridge's successor in control of the PC standard. Ruthless entrepreneur, why entrepreneurs leave big companies. Last story, the rise of the modern corporation, Durant versus Sloan. This one goes all the way back to the 1920s. The inventor of the modern corporation in the United States is a guy that if you've gone through business school, you might have heard of. Alfred P. Sloan. Lots of things named after him. Sloan School at MIT, Sloan Kettering Institute in New York City. Sloan truly was the president, CEO, and chairman of General Motors who revolutionized how large companies built and grew their organizations. He implemented an accounting system that allowed divisionalization, so companies can actually grow larger without becoming monoliths, which between World War I and II allowed enormous growth inside the U.S. and post-World War II allowed companies to internationalize and globalize and still retain financial control of their systems. He was an accounting genius, truly the father of the modern corporation. But he wasn't the founder of General Motors. This guy was the founder. His name was Billy Durant. The odds of any of you of ever hearing of this guy is probably 0. Durant had a great career. Before he built General Motors, he actually was the leader in horse buggies. Kind of like after watching the last presentation, probably like using Adobe Flash or something. Sorry. But he actually saw the future and moved into cars. And he started buying up separate car companies and put together something called General Motors. And he was crazy. You know, buying this, running out of money all the time. So his ward fired him. And he said, oh yeah? Okay, well I'm going to start another company. And he does. He starts a company called Chevrolet. Chevrolet grows bigger than all of General Motors. And he uses the profits from Chevrolet to buy up all the GM stock and throw out his board. Buys the company back. Gets another 10 years as the crazy CEO of General Motors, which now includes Chevrolet. But finally, again, he runs out of money and has to go to the bankers. And the bankers this time are the DuPonts. And so they come in and look around and go, this guy's nuts. And they throw him out a second time. When they throw him out, GM is the equivalent in 1920 of, in today's dollars, of $3.6 billion. Durant versus Sloan. Sloan dies rich, honored, and famous. Durant dies managing a bowling alley, penniless. He was the accountant. He was the entrepreneur. Thank you.
Washington, D.C. So just take a few seconds and see if you can figure out which one is which. So you'll see the one with the spike at 9 a.m., the spike at noon, and the spike at 5 p.m. That's Washington, D.C. The culture there is much more regular than in New York, where you'll see party time there in the evening, going till about 1 a.m., and then that slope as everybody finally goes back to sleep. And I just love that you can see the culture of an entire city by looking at the volume of traffic around the way people communicate there. So I also did a little search for who's talking about Web2 Expo by country. And it's not at all surprising, it's mostly here, but this is clearly a global event. It's very popular in Australia, which has a similar conference happening now as well, off in the UK, and then on from there. So this is pretty cool. I also wanted to mention that now 9.8% of our traffic is from mobile devices, and that totally changes the way people are using and sharing the data. And that number is trending up quickly, especially with the iPad. We also just had a new release at Bitly. It's called Fugu. You should check it out. You can now search your history and create your own personal analytics around your own data. And you can check out Bitly TV, where we're exposing trending topics through the segment of data that is videos on Bitly TV. It's bitly.tv. We're hoping to do more of this soon. And that's it. I'm Hilary Mason, H at Bitly, or H Mason on Twitter. Let me know what you think.
All right, so next up we have a little bit of a different kind of research. We have Jeff Pierce from the Mobile Computing Research Lab at IBM Almaden. And when Brady and I were talking with him recently about the research he's doing, he was telling us about how they've observed people using mobile devices and laptops and different email patterns. And felt a little creepy because it was as if he had been spying on us, and he's telling us what he'd seen us do. So there turned out to be some very strong patterns in usage. And what we're really grateful for is that IBM, who has the resources to do this research, is willing to come here and share it with all of us. Hopefully give us some insights that we can build on. So please welcome Jeff.
So I'm Jeff Pierce. I lead a mobile computing research group at IBM's Almaden Research Center. We've been studying smartphone use for the last couple of years, and we've been looking at sort of different patterns of behavior, looking for opportunities to improve user experience. And one of the things we've been looking at is email use in particular. One of the things we've seen is that a lot of mobile email clients are designed assuming that mobile email use is just like desktop email use. But if you look at the way people actually use mobile email, the usage patterns are actually somewhat different. In particular, when people are using email on a mobile device, they're in a very focused activity. They're looking for what's new, what can I delete right away, what's important enough I have to handle it now that it's worth typing out a message with my thumbs, and everything else they defer until they reach a laptop or desktop. But given the fact that most mobile email clients are not designed to support that particular pattern of behavior, they're really assuming that you're spending a lot of time in your email, you're opening up messages, you're reading them, you're responding to them, you're forwarding them. Mobile email clients really don't support the pattern of behavior of what's new, what can I delete, what do I have to handle now, and help me defer everything else. And so you see coping patterns. You see people that will spend most of the time just in the inbox, because just from the sender, subject, 2 lines to the body, people are surprisingly good at figuring out, what's this message about, do I have to handle it, can I delete it? And as a result, they don't open up a lot of messages. They can just glance at the inbox, figure out what they're going to do with it, figure out if they need to handle it. But because they don't open messages, the unread flag doesn't go away. And most mobile email clients don't differentiate between what's new and what's unread. And so when you glance at your phone and you see, oh, I have 10 unread messages, if you want to figure out if you have any new messages, and you actually want to look further to see what they are, you have to do the math yourself. You have to remember, okay, how many were there unread the last time I looked? Oh, okay, I've got 20, maybe I should glance at them now. You also see a coping behavior the other way, which is people will open up messages and they'll read them, and they'll decide, oh, I'm going to reply to this once I reach my desktop later on. But because there's no way of capturing that intended action, people will do things like reflag it as unread so that it captures their attention once they reach their desktop or laptop. And so we've been looking at, if you were going to rethink mobile email, how could you do it differently to support that pattern of triage, helping people figure out what's new, what they need to handle, but also looking at how do you help people support that transition from deferring a message on their mobile device to then resuming that activity once they reach their desktop or laptop. Okay? So we've built a prototype mobile email client to help us explore some of these issues. We're doing a couple different things here. First of all, instead of just showing you the inbox when you start, we're actually breaking your mail down into triaged and untriaged. Where triaged is you've already told us how you're going to handle it, and then untriaged is you haven't given us that information yet. So one of the things we can do here, for example, is once you've told us you're going to defer a message until you reach your desktop or laptop, you don't have to keep looking at it and remaking that same decision over and over again. We're also breaking out separately the number of new messages, the dark blue, unread, and then read messages. So we can support that pattern of behavior where you glance at your inbox, figure there's something that you're going to handle now, and then the next time you fire up your email client, we can tell you exactly how many messages are new from the last time you looked. Once you actually look at your untriaged email, we're also applying a blue background as an additional visual cue to really help you zero in on what messages are new. To help you figure out, where should I pay attention first? What's the thing that I probably most care about looking at? We're then using a blue circle to indicate unread status if you do want to look for unread messages. We also saw when looking at mobile email use that when people were figuring out which messages were important, one of the things they wanted to know was who else got this message. So if you get a request for some information, it actually matters a lot to the message's priority if it's just to you versus, your whole team got it. So we use green circles. A filled green circle is just to you. A half-filled circle is you and a small number of people. An empty circle is a large number of people. And then no circle at all is an indication that you're not addressed by name or you're BCC'd. So additional visual cues to help people figure out, what should I pay attention to, what's important. Those are some changes we made to help people better triage their messages. We're also looking at the second part. Once you've decided you're going to defer handling a particular message until you reach some other device, how do we help people capture the decisions they've already made about, oh, I have to reply to this person, I have to schedule a meeting, I want to make sure I print this out, I have to visit this website. And so we're using a cloud service behind the scenes to help capture those intended actions so that people can access that same information once they reach that other device. So in particular, when you're looking at messages in your untriaged view, we allow people to pull up a translucent overlay on top of their messages. So they can quickly assign that a message is something they can do next, something that is deferred, waiting for someone or something, or something that's a reference. So it's not a task in and of itself, but it's information that's useful for some other task. We also allow people to assign actions. So you can assign that you need to reply, you need to call someone, you need to schedule a meeting. There's a variety of actions you can assign to those messages. Once you're done specifying what actions you intend to take on those messages, you can hit a triage button, and then we'll do a couple of things behind the scenes. First, we'll move those messages from the untriaged view to the triage view. So next time you look at your untriaged mail, you don't have to look at them again. We also, behind the scenes, create tasks that correspond to those messages. So we take the message subject and use that as the short description of the task. We take the body of the message and we use that as the full detailed description of the task. And then we synchronize that information with the cloud behind the scenes. So we're using a service called Lotus Activities to capture that information. So you can access it from a web browser if you want to. But also we have a plugin for a mail client on your desktop or laptop. So once you come into work, you can access that information. So a pattern of behavior we often see is people will pull out their mobile phone in the morning before they go off to work. And they'll quickly triage their mail. What can I delete? What don't I need? What do I have to handle now? They can capture the intended task for the deferred messages, and then once they reach their desktop or laptop at work, they can jump right in. They have the set of captured tasks around those messages. They can get started right away. They don't have to rescan those messages and remake those same decisions. So the view in the desktop client, you can pull up those tasks, you can access and edit the details. You can also double-click on the mail icon, and it'll help you jump back to the original message again. We also provide access to those same tasks on the mobile device. So, some tasks like making a call are actually more easily performed on the phone. So we don't just look at supporting transitioning those captured activities from the mobile device to the desktop or laptop. We also look at providing access to them on the mobile device itself. There's a video that actually shows what this interaction looks like. You can actually see what it might look like in practice to triage messages, to capture those activities, to access them later on the desktop device. So that's just sort of a quick glimpse of some of the work we're doing into looking at supporting mobile usage practices based on observation of real use. So one of the things we've seen is that mobile use does differ from desktop email use. And it's a real opportunity to rethink not just the mobile experience itself, but also how that mobile experience fits into the desktop and laptop experience. And we've been looking at creating some prototypes around this notion of supporting triage and the capturing of intended actions. Thank you very much for your time.
Thank you very much, Jeff. Mobile is really on the rise, obviously, as we've really focused in this conference. And it's important to realize that it's not just the same as the web currently exists and how you access it through the desktop. And so we'll continue to bring out researchers who are thinking about new ways to interact with mobile. Now, the rise of mobile users is also affecting the technologies people choose to use. And that's the case for our next speaker. Please welcome out the Cto of Scribd, Friedman.
Thanks, Brady. Hi, I'm Jared. I'm one of the founders of Scribd, and today I am really excited to finally get to talk about something that we've been working on in secret for a long time. I couldn't think of a better venue to launch this at, because what we're doing plays directly into a debate over Flash and HTML that has been raging at this expo. I'm sure that you've all been following this. The short story is that after 3 years of building on Flash, Scribd is starting over and moving everything to HTML5. I think that this is the largest deployment of HTML5 to date, and I know it's a bet-the-company decision for us. This presentation is the story of that decision, and I hope that it is useful to you as a case study for building your own HTML5 apps. Scribd is the largest social publishing and reading site with over 50 million monthly unique visitors. Lots of content has been shared on Scribd, and people come mainly to read that content. Today, they read it using our Flash document reader. It looks like this. Now, incidentally, Flash is a terrific technology, and it's very useful in a lot of situations. But for Scribd, for reading documents, it's always had a few drawbacks. They boil down to the fact that you are putting the content inside a separate application. This leads to a browser and a browser problem where we end up duplicating the built-in functionality of the user's browser ourselves. This is, 1, a lot of work, and 2, almost inevitably a bad user experience. So one night we were sitting around and we went back to first principles. And we asked ourselves, why do you need a special reading application just to view a document? After all, people are reading more and more in browsers. You read blogs in your browser. You read the New York Times in your browser. Browsers are meant for reading. So why should documents be different? Well, it turns out that the biggest challenge is formatting. See, documents routinely use very complex formatting. Vector graphics, rotated text, precise positioning that is difficult to replicate in a web page. Until recently, browsers only supported a dozen fonts. Fonts are actually critical. Without the right fonts, you can't reproduce the appearance of the document correctly. At least not without converting the text into an image. This is an approach that some products have taken, so I want to address it. What they do is they take the text of the document, they turn it into an image of that text. This solves the formatting problem. But the reality is that images break the web just as much as special plugins do. Imagine, tomorrow morning, you wake up, and overnight, an evil gnome has gone through the web and converted all the text into images of that text. This would suck. Search engines would break. Browser search would break. Zooming would break. Text selection and copying and pasting would break. Deaf people couldn't listen to the content. Mobile devices couldn't reflow it. And ad networks couldn't understand it. Everything would be broken. Text is like the glue that holds the web together. You can't just live without it. And now, you don't have to. Over the past few months, every major browser has rolled out support for custom fonts through the font base element and vector graphics through either Canvas or VML. Today, browser support for these features stands at 97%. Yes, we can support 97% of browsers in the wild, including IE6. This means that browsers are now finally powerful enough to display any document natively. Or at least that was the theory. When we first started working on this project 6 months ago, no one knew whether it was really possible in practice. We had to extract over 1 billion fonts across tens of millions of documents and get them all to render exactly the same way in every web browser. Web fonts are new technology. No one had pushed them that far. At the same time, we were preparing to abandon a 3-year, multi-million-dollar investment in Flash for an unproven idea. Honestly, it was not an easy decision. And I think this will be a common theme of HTML5 projects. That is, with any real innovation, there is an element of risk. In Scribd's case, though, it worked out great. And it works just as well on mobile devices. See, that's the beauty of HTML. It's the lowest common denominator format, so everything supports it. Every mobile phone, tablet, e-reader, they all support HTML. And increasingly, they support HTML5. So Scribd got access to this entire mobile market. And we did it without having to write a separate app for every mobile platform. Let's see this in action. This is a magazine with rich formatting, so it really shows off what we can do. The first thing that you'll notice is that this is an ordinary web page. The content is no longer in a box, so I scroll it as normal. We built this bar down here at the bottom to make it easier to navigate through long documents, but actually it's not necessary. Everything in this bar you can do using your browser's built-in functions as well. It is helpful, though, if you want to jump to a particular page. Like here, I know I want to jump to page 18. Now, check this out. I'm going to highlight some text, and I'm going to copy the text, and I'm going to paste it into my browser's search function. And you can see that this all actually works because everything here is ordinary text. Now, let's look at a presentation. This was originally a PowerPoint, but now it's being displayed in HTML5. HTML is a great experience for reading presentations online. It's so natural. If I want, I can flip the PowerPoint into slideshow mode, where it displays like as if I were presenting it. Or if I just want to read it on my computer, I can move it back to scroll mode. And because this is all online in a web browser, I have access to all the social functionality I expect to find on the web. Like right now, I'm going to recast this presentation or share it with all my friends on Facebook. Done. Now let's look at this on the iPad. This is a document rendered in pure HTML5 on the iPad. You can see that the text and graphics came out just beautiful. Because this is online, all I need to do is pan right a little bit, and I get access to all of Scribd's social functionality right there. So easy. When we started Scribd 3 years ago. We had a simple vision. We wanted to make it really easy for people to publish whatever they had written on the web. I would say that until now, until HTML5, we had not fully achieved that vision. It just wasn't possible. So that's the story of how open web standards made it possible for Scribd to achieve our vision. I hope they can help you achieve yours too. Thanks.
All right, thank you, Jared. That was really pretty interesting. When Jared first showed us the demo.
Exactly a computer you wanted, but a group of guys with brains and a group of boxes with electronic brains and consoles and displays, all connected together in varying ways and growing together.